Hello everyone, welcome to the TSS. So we finally came to the most exciting stage in the data science project life cycle, that is model building. Because uh, from this stage the magic will happen, friends. Why? Because so many machine learning algorithms and statistics, mathematics comes into the picture. So let us discuss this model building stage. So after analyzing the data and the relationships, we need to select proper model for model building, friends. Okay. So in the earlier stage, we had already saw the analysis, how to analyze these data, everything. We need to analyze the data columns and the relationships with each other, and which columns is most suitable uh, for us to build a model. Okay, so that columns we have to select for model building, and also which model to select based on the data, based on the business requirement, that also you have to uh, sort out. Okay, and then we came to the stage of model building. After deciding which model to use, we came to the model building stage. So and then we will start building the model. So then what is model building? Okay, let us discuss what is model building, what will happen in model building. Let us discuss that. Model building means training the appropriate model by feeding the data, and then let the model learns from feeded data, and then model will predict the outcome without explicit programming by programmer. So let us read it again. It's worth. Model building means training the appropriate model, the selected model, by feeding the data. We have to feed the data, okay, which we have analyzed in the earlier stage. That means we need to input the data to the model. Okay, that is that means we need to train that model by feeding the required data, and then let the model learns from the fed data. Then what it will happen, what model do? So model will take all those data and it will learns from the data. So this is where the interesting topics comes into picture. So how the model learns? It is the magic, friends. Okay, so it is the magic of mathematics, statistics, and all those algorithm, friends. So by feeding the data, the model will takes up all this data, and then it will learn the things about the data which we feed to it. Okay, and then the model will predict the outcome. So then what the model will do? It will predict the outcome. How? It already learns from the data which we have fed, and if any uh, further say some event occurs, then it will cross verify with its previous learned data, and it learns something about this previous history, and then it came up and it predicts the probability of the outcome automatically. Okay, so without explicit programming, this is very important word. Without explicit programming means we what we are doing is we are not programming the model. Please here, please listen concentratedly. We are not programming the model. Okay, programming the model means so we need to direct the model. You go and you select it, you go and you do it like that. That is called explicit programming. So that is what the general software engineers and programmers are doing. So we take up the problem and we write the code to what task to accomplish. That means we are directing the computer to do the task. That's it. But here, what we are doing is we are simply feeding the data to the model. So the model is learning from the data. How it learns is the important concept that will comes in the machine learning algorithms. So for each algorithm, each mechanism is there. How the model is learning from the data. Okay, so that is the power of mathematics and statistics, friends. So by all those mathematics and statistic, probability, calculus, linear algebra, all those principles it learns. Okay, then it will come up and predict the outcome. So uh, uh, we didn't direct that model to do it explicitly. Okay, so the model itself will learn that. Okay, so by making use of machine learning algorithms and the mathematics, friends, this is the very important point, that is called the model building. What is model building means, this is the answer. Okay, so this is the stage where all machine learning algorithm models, mathematics, statistics, probability, uh, all those things comes into picture, friends, and this is where the magic begins to happen. Okay, right? So this is very very interesting stage of the data science project. Here, in order to build the models, we need the knowledge of different machine learning algorithms and their underlying mechanisms. Okay, so model building is not that much simple. We need to understand the machine learning algorithms and their underlying mechanisms. So it is for reading it is very simple, but studying the machine learning algorithms and underlying understanding their underlying mechanism is not that much simple, friends. Okay, and um, it is not the scope of this class, because I am just introducing the stages of data science, typical data science life cycle, project life cycle. So machine learning algorithms, for each machine learning algorithm, approximately it will take 2 to 3 hours time to teach. So this is out of scope of this class. In some time in the future we will discuss all those things. So how the model will learn means, it will make use of different machine learning algorithms. Okay, so uh, for which algorithm should we use, that will depend upon the our business requirement, friends. Okay, so this is all about the theoretical part of model building. So let us see the scope of tools we are going to use in this model building stage. So we can make use of scikit-learn, which is a famous library for machine learning and this all these mathematics kind of things, and also some mathematics we will make use of in this stage, friends. So the scikit-learn will have all the ready-made machine learning algorithms. Okay, so we don't need to take up the pen and paper all again and do all the calculations, calculus, algebra, differentiations, integrations. Okay, so the statistics and probability, all those kinds of things we need not do. We You should only know the machine learning algorithm concepts and their underlying mechanisms. You need to understand, because if you don't understand, if you simply use this code, it doesn't make sense. If any problem comes, how you can rectify that problem? That's where you struck up. Without mathematics and without the knowledge of functioning of the machine learning algorithms and the associated mathematics and mechanisms, you will always struck up somewhere. So that's why understanding the machine learning algorithms and their underlying mechanisms is very very mandatory skills, friends. Okay, so these are the tools we are going to use. This is the In this library, this is the machine learning library of Python. It is also open source. So all the machine learning algorithms are prototyped and made available ready-madely in this scikit-learn library. So let us see what are all the machine learning models we'll make use of for different types of our business requirements. So there is a linear regression, the machine learning algorithm called linear regression, and I will make a short note of this list of machine learning algorithms here. So what is linear regression means? It is used to know the continuous variable. Okay, it's used to know the outcome of a continuous variable. So if the best use case is meteorological department, so weather prediction. So whether if you want to predict how much temperature uh, will going to be recorded from tomorrow. Okay, if you want to predict that, you need to make a model by feeding all the required data, how much humidity is there, how much clouds, all those meteorological jargon terms you need to feed to this linear regression model. So from last 30 days, how what are all the conditions and what are all the temperatures, all those history you need to feed to this linear regression model. Then it will train after it will take uh, uh, it will train by analyzing that all those data, and then after training it will learn from that data. Then it will predict if you give some parameters, then output will give. Okay, tomorrow the temperature will be say 32 degrees centigrade. So how it predict that 32 degree, 32 is a numerical in nature, that is a continuous, not discrete. Okay, so for that kind of things, linear regression is the model to use, friends. Okay, if the predicted if the business requirement is to predict the continuous variable, let us take one more example. Sales. Okay, how much sales will happen? Okay, that is the number to predict. Okay, it is um, so the money. Okay, say some 10,000 or 20,000 or 50,000 rupees sales, or say 1 lakh or 1 crore. So it is a numerical variable. Then linear regression is a relevant model to build. And if the business problem is like yes or no thing, or whether uh, the tomorrow whether rain comes or not. Okay, it's not continuous or numerical variable, yes or no kind of things. Okay, so tomorrow whether rain comes or not, whether the political leader wins in the election or not, this kind of things, whether our India wins or not in the match, and whether the play will goes on or it will be stopped because of the weather condition. Like that, so many things, whether this person, this patient is having is the chances of uh, cancer disease, chance of occurring the diseases is there or not for a patient. This like of things, yes or no kind of things. Okay, so that is called discrete things. So for all those discrete kind of things, predictions, we need to use the classifiers. Okay, so logistic regression, KNN, decision tree, random forest, navy base, all these five, 1, 2, 3, 4, 5. These five algorithms are there. Some other algorithms are also there, but the most famously used is this one. KNN means K nearest neighbor. So the methodology and the mechanism by which it will predict will differ from algorithm to algorithm, friends. These are all the machine learning algorithms. One is linear regression, that is used to predict the continuous variable, and this one logistic regression, KNN, decision tree, random forest, naive bayes. These five are used to predict the categorical variable. That is, categorical variable means discrete things. Okay, yes or no, like that. So KNN means K nearest neighbors. It will predict the new entry point, and it will compare it with their nearby values. That means nearby neighbors. Then it will comes up whoever majority uh, neighbors that the new data point matches. Then it will comes up and say so. Uh, it comes into this category like that. So decision tree is make use of tree like decisions root node. It will split for every node. It will split, the decision splits will happen. So all these machine learning algorithms will take very much time to explain, friends, because we need to explain the underlying mathematics, statistics, probability, and then the Python code like that. Okay, so in this class, the scope of this class is just to explain you about what are all the things will happen in this stage of data science project, and the tools we are going to use, and the machine learning models which we are going to use. So, okay, so decision tree, random forest will make use of number of decision trees to take the decision. So it will say, if suppose a random forest make use of 5 decision trees, some each decision tree will output one decision. So then the random forest will take the majority of the decisions. If the five in the 5 decision trees, some 3 decision trees will say yes, and if 2 decision trees will say no, then the random forest algorithm will pick up the 3 decision tree majority decisions. So and then it will finally say yes, like that. And naive bayes is the beautiful algorithm based on the probability, naive bayes probability. Okay, conditional probability. And then K means clustering. K means clustering means it is see, these are all supervised learning, friends, because we feed the data, the history of the data, which is having both the data and the value to be predicted, and the history of the data. We train this data. In the training session, what we are doing is we are giving the uh, data to be predicted also as a history, right? So after training session, the model learns, and then it will come up and say, and will predict the uh, continuous variable or category variable depending upon the input data set. So these are all the algorithms that comes under supervised learning, friends. Linear regression, logistic regression, all those things. And the unsupervised learning is also there. The machine learnings, it will uh, split into 3 types. That is supervised learning, and the number 2 is unsupervised learning, and the number third mode of learning is reinforcement learning. So all these machine learning algorithms will come under, up to naive bayes, it come under supervised learning. And the K means is unsupervised learning. There is no training session. Just if fed the data, and it will classify it based on the underlying mechanism. So clustering is very very important, friends, in the areas of clustering. That means grouping the data, document classification, emails, so classification, all those things. So much of applications are there for k means. So and the neural networks, if the data to be uh, detected or predicted is say something like an image or the audio speech, natural speech, then the deep learning and neural networks comes into the picture, friends. Okay, it is called the deep learning because the deep learning is the word which we use when if we use the neural networks to solve our problems, friends. Okay, so deep learning means the neural networks which are going to use is some stages of neural networks. So some levels of neural networks are there. So many levels of neural networks are there, combinations. Okay, so multiple neural networks are there. The depth of the neural networks are uh, very high. So from that the term deep learning came. Okay, so from one stage we the problem needs to cross one neural network. Okay, so in each neural network some weights will be added, then the output there will be the output function will be there. Okay, so all those things will come up in the deep learning and neural network, friends. And then the NLP, very nice topic, natural language processing. So that is called text analytics. Okay, so all those things we are going. This model building will make use of, friends. All these use cases will depend upon your business requirement, what you are going to accomplish. Okay, so based on that, the selection of these algorithms will depend. Okay, friends, this is all about model building, and let us see the classification of this algorithm, friends, so that you will get the clear cut idea. Here is the classification, friends. Okay, so machine learning algorithms classification. If the requirement if your requirement if your business requirement is to predict the output is continuous variable, then we'll go for linear regression model. So if you want to predict the categorical variable kind of things, that is discrete things, that is yes or no kind of problems requirements, then you need to use logistic regression, decision trees, random forest, KNN, naive Bayes. Okay, so on these models will not make sense if you want to predict the continuous variable. And likewise, similarly, the linear regression will not relevant and doesn't make sense if you wanna predict the categorical variable kind of things. You need to select your models appropriately. Okay, so then if you wanna cluster group the data kind of things, then the better algorithm to use is k-means clustering or hierarchical clustering, PCA, like that. And then if you want to recognize the audio or an image, then you should use neural networks. Okay, you should not use linear regression or decision tree, all those things for recognizing the image or audio. Okay, you should use neural networks. In other way, it is called a deep learning, friends. Okay, output, if the output is an association. So in the recommender systems we already discussed in the application section of the data science, the recommender systems. If you buy one product, the website, the Amazon or Flipkart will come up and say, let us try this, it may be useful to you. So it will suggest the relevant product uh, to you. Okay, which is relevant to already purchased product by you. So how those websites will know, that apps will know your purchase behavior and come up and suggest and recommend some of the items to you. So that is by the use of the algorithms called a priori. Okay, so this is for that kind of business requirements. And if the requirement is non-linear interaction of data, the bagging and boosting methods will be the relevant models, friends. So, and these are all the brief classification of machine learning algorithms. according to your requirements. Okay, so according to the requirement, business requirement, you need to choose proper algorithm. So in case if it is categorical, there are so many, 1 2 3 4 5. These 5 algorithms will uh, be used if you want to predict the categorical yes or no kind of things, whether this patient will have the disease or not. The probability of occurring the disease to the patient is yes or no. So for that kind of business requirement, medical requirement, you can use logistic regression, and at the same time you will use decision tree, KNN, random forest, navy bay, all these 5 you may use. But which should we select in these 5? If you have a doubt like that, then we can say that there is no perfect algorithm for a given in all situations, friends. Okay, there is no one master algorithm for all situations. We must be scrupulous enough to understand which algorithm to use. So the best method is you try all the algorithms. Okay, with your data set you train all these algorithms and you evaluate all these 5 algorithms. So whichever algorithm provides the most accuracy, let us stick to that algorithm. So this is the general practice which we are going to uh, use in the real time data science projects, friends. Okay, so this is all about machine learning algorithms and their classifications and the model building, the theory part. Okay, so in the next class we will see the next stage called the fifth stage of data science project life cycle, that is model evaluation, friends. Okay, till then, bye bye. Your Svira signing off. Thank you for listening.